Afternoon, everyone. My name is D. Kumar. I'm a cloud solutions architect on the data and AI platform. Have been working with Microsoft for almost 3 years now. And before coming to Microsoft, I would say my experience has been on the analytics side. So I have been on this side for almost 2 decades. But what has changed here? And I'll also try to bring that approach of how analytics approach has changed along with what Microsoft offers across to support these data lake, data warehouse, the storage platforms, and there is a lot to cover along with IoT data ingestion. So in the next 20 minutes, I will try to cover through this, and please feel free to pose any questions so we can take that after the call or during the call, like depending on how much time we have left. So, all right. So talking about analytics, I have been like most of you would have been too, have seen how the world of analytics on the business side or in an organization has changed. We have gone through a revolution here with the type of data we have been dealing with and the kind and the velocity and how the data has been coming in different varieties to us. So our systems had to change, our processes had to change, but fundamentally there are two approaches to work through analytics. One is the top-down approach, and one is the bottom-up approach. The top-down approach, this has been the traditional approach, where when we start, we kind of have an idea as to what we want to build, what is the hypothesis, what the data sources we'll be dealing with, what kind of data we will be dealing with. And we just have sample data to work with, not a lot of data, but still our theories, and that is the way how we used to build our platforms in the past. Like when I started in the data warehousing side, maybe in 10, 15, 20 years back, this is what was the process, the top-down approach. This approach serves a great purpose. It lets you look at the data. It gives you the capabilities to do descriptive analytics, diagnostic analytics. For example, like I was with one of the big retailers. They used to run promotions. So you would know once you ran a promotion, like what happened? Was it successful? Was it not successful? If it was successful, what were the features? What products, with what markets the product flew off the shelf? But if it did not go, what was the reason? So the diagnostic, it supported these kind of models or this kind of approach helped you or helped anybody with doing the diagnostic and descriptive analytics. But then the other side had to come up. Like I said, the data was now coming as not once a day, but it was coming many times a day. So data had to be handled with the capability and capacity on the technical side. But along with that, the type of data, the volume of data was coming in from so many sources that the traditional systems could not handle that kind of data. And that's where the bottom-up approach started making sense. So a decade back, people started coming up with, okay, there was a big chunk of data we were ignoring, even though it gave you like some pointers. Not all data should be loaded in a high value compute, but there are some good indicators which would help you with the predictive and prescriptive analytics. So that's where there was a change in the market or in the organizations where we saw the advantage of having data stored in a low-cost storage, all sorts of data. You could ingest the data from your sources, store it in the native format, But still, from that data, you could use the right kind of compute to analyze that, batch queries. You can see what is a high value data and then land it into data warehouse. You can see what, if you want to look at what kind of to do any machine learning or advanced analytics. That was the source for all kinds of analytics coming into an organization, and that was also a source, or that is now a source where you could now take the data into multiple analytic platforms. So now the question became that, okay, does data lake be the is can that replace a data warehouse? Can that replace traditional systems? People did go on that bandwagon. They totally eliminated data warehouses, started using Hadoop, started using Spark, and they thought, okay, this is one solution for all the problems. But really, that did not work further, because it's not just one size fit all or one solution fits all approach. There has to be a combination. And that's where there are certain legacy operations or certain operations where you need to have the data available to users at a very low latency. But at the same time, you do need the data lake. So we want these to coexist in an organization. And how would they coexist? So there were silos created, and the one silo would go for, okay, I want a structured system, and that's where they wanted the data warehouse, and that other one was the unstructured or whatever structured, semi-structured form. That's where the data lake existed. But then going forward, there had to be made a balance to in terms of the SLAs, in terms of the speed of response, in terms of how you service your end users. And that's where, like, if you look at a data warehouse, even though it's a top-down approach, it does address the concern of integrating data from multiple sources. So that continued in organizations where we were having a corporate strategy, gather data from multiple sources, bring it together, do the modeling, do the ETL design, set up the infrastructure. So the data warehouses did, and even today they do exist in organizations to support the legacy systems or support the needs of not only legacy systems, the needs where an organization doesn't have to deal or doesn't have any unstructured data. But then, when we are talking about having a data warehouse, and we are talking about the data lake and the relational platforms, we need to see exactly what the end users are looking for. So that's where what I'm going to go through next is a couple of slides to showcase what Microsoft offers. And the big thing which I want to highlight, or one lesson from this session, is the integration we offer, be that a data warehouse, be that an operational system or a transactional system where you're bringing your data, be that any kind of office applications. It could be a system, a NoSQL system, but what is the strong point with the Microsoft ecosystem is the integration. We offer end-to-end integration, and when I go through further, we'll be talking about you do not even need an ETL now for moving your data from transactional systems to your analytic systems. So going to the next stage, where it's like Azure Storage and analytical platforms, the foundation of all our foundation storage for all our systems is the Azure Data Lake storage, and we call it as the Azure Data Lake Gen 2 storage. The advantage here is this: we used to have two different kinds of storage. One, the traditional blob storage, where you could store objects in any form, and then there was other storage for users who were doing advanced analytics. So it was called the Azure Data Lake storage, where you could give folder level access and ability to do like file level operations when you're working through it. But in 2019, we merged the two capabilities, calling it the Azure Data Lake Gen 2. So now you can enable the advanced analytic capabilities you need on the backend side by using the Gen 2 API or ABFS driver. So most of the operations can be very performant, along with the traditional blob storage where you store data for images, music, or any form of data or any backups in the traditional blob storage. The advantage here becomes the granularity at which you can work with the folders. And this being the foundation of rest of our platform, we do have certain features like ability to replicate the data locally, ability to have it in a zone, ability to have it geo-replicate the data, and have those have your data totally secure. So this foundation being the blob storage, the other thing you get is ability to tier your storage. That is like, okay, your data is in a hot storage for 30 days, but after that, you do not access it that much. It doesn't have to be in an expensive storage. You can move it to the cold storage. So all those policies could be built at the storage layer, and those are things which any storage platform, if you have to compare like three clouds, the capability which Azure Storage gives you is phenomenal in terms of performance. Because if you go, the blob storage earlier, our folder structures were very similar to what you find across other clouds too, but they were not the more performant because it was not a true file what do you call a file, a directory layout. But now you get that. So that is one distinction which keeps that Azure Storage having a very performant way to manage your analytic workloads. Then data encryption. Your data is secured. It's secured in transit, and also we do have client-side encryptions. Next comes to SQLs. The SQL databases, the relational databases, they were things like people were in awe with for storing their data for quick access, relational data modeling, and SQL. Like Microsoft came up with the first SQL Server product in 1989, and now we have millions of installations. And if you see, there are so many flavors of SQL available on-prem, on Azure. Within Kubernetes, Edge, so we have so many flavors of it. But if you talk about Azure, there are the SQL virtual machines. Our different flavors are like you can lift and shift your machines into a VM, the SQL virtual machines, but at the same time you have the managed instances and the Azure SQL databases. The managed instances, if you want to lift and shift, you do not want to manage patching and backing up your databases and all the administrative stuff, then this is the platform you go to. So typically customers going for lift and shift go across these two, either SQL VMs or managed instances. However, if somebody is building modern cloud applications, that's when the SQL databases come into the Azure SQL database, which supports not only your serverless and other options, but the big thing is the hyperscale, where you can scale up to 100 terabytes with very, very performant response times. So coming to that, when we're talking about storage platforms, the other one is the Cosmos DB. When you talk about when you're looking for something massively like scalable, where you want to your geographies are distributed, you want like very, very strict SLAs, that's where Cosmos DB is something which people go for. It supports SQL API, MongoDB, Table API, Gremlin, but the big thing is that it's globally distributed, elastic scale, and it has 5 nines of guaranteed low latency. And it is one of the databases where we offer performance guarantees and we pay money, financial guarantees here for low response times. So coming to the last platform here, where we talked about data lakes, data warehouses, SQL, NoSQL databases. What did it do to organizations? It created silos. So the data science workloads and the data scientists preferred data lakes because that enabled them fast explorations. They could look at the data before they even landed it, and if they wanted to really work with it. So it provided an exploratory what do you call environment for them. But data warehouse that's where most of the business decisions or reporting happened because it had a dependable performance. It was people were very comfortable with the security level and all that. But what it did was two different silos. Both of them needed different skill sets, so it was hard to reconcile them or bring them together or try to bring the reporting together at one place because of the skill set. So what came as a response was Azure Synapse Analytics from Microsoft's side, hearing from the field that to provide a unified platform which brings together the data scientists, the business analysts, and the data officers, everybody together into one single native cloud service. And this is where our story of integration begins, where on the left side you see all the data sources, on the right side you see the integration with data governance platforms, the other data share, machine learning, reporting platforms like Power BI. But if you look at it, the foundation of this Azure Synapse Analytics is really like it makes things so simple and easy for folks to work with that this has a dedicated tool, an engine. We talk about SQL engine, where you get the relational component of it. And the relational component of it, or you can write SQL on data and have the same relational constructs. And that's what we call it, the data warehouse. But you could also, one thing it enables is write SQL on top of data lake. So the data scientists, which had needed the Spark skill or Python skills or data science skills to look at the data coming in non-format, which the other analysts couldn't see it in Parquet or ORC format, you could see that, or you could work with that, explore with that. So this brought in the data scientist and the analyst together. Similarly, we have the Spark engine. So Spark engine enables you to do those doing those handling those streaming workloads if you need to work with Spark, or any data scientist who is very comfortable working with Spark has an environment to work with there. Other than that, Data Explorer for anybody working with telemetrics data, IoT data, near real-time data coming at a massive velocity, and you want reporting to be done. This integration with Data Explorer was announced last month. It's in public preview. And I would say within a month, I've been working on 5-6 POCs where customers have been trying to bring in the IoT data and try to derive insights, and it's a great integration which has been brought into Synapse. So the thing is, within Synapse, because the security has already been managed, it's a managed identity access. It makes working with your data with the data so easy here, and also to be able to cross-report with whatever you have built in across different environments. Other than that, when I talked about the SQL engine and the Cosmos DB, we have something called Synapse Link. Traditionally, having worked in analytics, I see like at least 60 to 70% of the time people are doing ETL workloads, trying to derive insights and all that from the different systems, and they're trying to work through them. But what Microsoft has been doing that since most of our systems have reached a maturity now, based on feedback, we have tried to connect the Synapse link. So basically what that does is any transactional systems, they do not allow access to analytic queries during the daytime or when there is high transaction workload. But with Azure Synapse link available for Cosmos DB, that transactional data gets visible and available for reporting within Synapse within a minute, within few seconds. We try to save a minute or 60 seconds, but as soon as a change happens, without writing an ETL, there is that integration that you can work through that data. Nobody's going to stop you from accessing it because it's stored in a data lake. Similarly, with SQL DB2, we announced an integration 4 months back during Ignite. And that is where you do not have to move data from SQL DB anymore. All you need to do is enable Synapse Link. So now that data is visible and available for access and reporting within the Synapse workspace. Other than that, if you were working with any of the Microsoft applications like Dynamics 365, Office 365 Power Apps, we have Dataverse. So the moment you activate Synapse Link there, that data is again available to you within Synapse. So that's why we call it as a limitless analytics, or a platform for converged analytics, because we realize that, oh, there are different systems our customers are using. What if we can enable them to have everything at one place? And that is where we have been releasing these links to our managed service platforms. And there is more on our roadmap coming forward. So this is a big change, and this is what we have seen. As I personally have had a lot of experience on working with customers on this side of things, where we have eliminated ETL to ingest data from multiple source systems. And talking about Data Explorer, this used to be a separate product, but this has been specifically targeted to run log or telemetric analysis or IoT data. So that is what this Data Explorer integration is with Azure Synapse, to give a unified experience within Synapse for any organization. So now coming here, not going into much of detail, but here the data pool architecture, this is really IoT focused. The data from IoT, Event Hub, Event Grid can be configured to continuously load into the data lake and be processed and made available for our reporting side, like Power BI, UI dashboards, Power Automate, as soon as it comes in and lands in here. So this is really, we talk about it's a distributed query engine. Everything happens in memory. All you need is it's a auto pause and auto start kind of workload for Azure Data Explorer. Data is super compressed. All the data is fully indexed. Excellent for JSON processing and unstructured data free tests, and users, like, you have so many options to provision it, and it does offer workload management, policy-based access, and you have the ability to create external tables to access data from your blob or data lake or SQL systems. So this is our latest integration to enable IoT workloads. So use cases for Azure Data Explorer, build near real-time big data analytics on custom events and logs data, centralized near real-time availability of solutions, observability solutions from all telemetric sources, any security or any log analytics where you are trying to look for data related to security breaches, IoT analytics solutions. That's where this integration has a big impact. So this is like, I didn't get to, I don't know how much time I have, but I think I'm done with my time. But this is like really, I had a demo where had we had time, I would have gone through it, but just wanted to show this architecture here. Like on the left side, if it's a manufacturing company with the data coming in from multiple sources, SAP, Teradata, we have, and there is telemetry data. Synapse has all the built-in ETL integration tools, all the connectors to connect to Oracle and build that logic to read the data from that sources and enable to do run machine learning, cognitive services, or search on that data. At the same time, for the hot path where the data is continuously coming from our machines or sensors, that data through IoT Hub is available within Azure Synapse. And if the data is going to Cosmos DB, Synapse Link without any ETL makes that data available. And here, if you're running any stream analytic, that data can be directly fed into Synapse dedicated pool. So this is an end-to-end architecture showcasing the integration story that, okay, once you have created a workspace here, we have that Synapse link available from Cosmos DB, from SQL servers, data lakes, to be bringing the data in and integration with the machine learning cognitive services. So you do not spend time ingesting and moving data. You just focus on, okay, what can we do with it? Power BI or trying to work on deriving insights. So that is an effort we have been trying to make and have been bringing in enhancements. I didn't get to talk about the data integration side of the data governance piece of it, that is also an integration which we have now with Azure Purview. No matter how your data is moving through an organization, Azure Purview lets you see the data lineage going from point A to point B, and we have been onboarding as many connectors as we have on Azure Synapse, which is more than 100 connectors, more than 100 connectors on Power BI, and same thing with Purview. So not only you're seeing how your data is getting integrated, but at the same time, if you are to build governance on it, we have Azure Purview available. Data sharing, that is another thing which has been integrated within Azure Purview. When you share data externally, you have that lineage also brought into our governance platform. So I think this is where I would like to put an end to my presentation.